Hello and welcome to Mr. Alvarez's virtual chemistry classroom. Today we'll be learning about Table M, Common Acid-Base Indicators. Our aim for today is, how can we use Table M of the chemistry reference tables to determine the pH of a solution? An indicator is a substance that will show different colors in acid and base solutions. Therefore, they can be used to indicate whether a solution is an acid or a base, based on their color. The color of the indicator is sensitive to the pH of the solution. An indicator changes color at a particular pH or a pH range. Table M of your chemistry reference tables has common acid and base indicators. So as we said before, Table M lists some common indicators, the approximate pH range for the color change, and the particular color change. Usually, the indicator changes color gradually from the color shown at the low pH to the color shown at the high pH. Here we have Table M of the chemistry reference tables. Table M is common acid-base indicators. In the first column, we have the indicator name. There are 6 of them: methyl orange, bromothymol blue, phenolphthalein, litmus, bromocresol green, and thymol blue. In the middle column, we have the approximate pH range for the color change. And in the third column, we have the actual color change. For the first one, methyl orange has a pH range of 3.2 to 4.4. That means at a pH of 3.2 or below, this indicator, methyl orange, will be red. The pH value, the number on the left, corresponds to the color on the left. Consequently, a pH value of 4.4, so if methyl orange is placed in a solution with a pH of 4.4 or above, then the methyl orange will turn yellow. The number on the right of the middle column, the pH value on the right, corresponds to the color on the right. Let's jump down to the third one, phenolphthalein. Phenolphthalein is an important acid-base indicator that is used during titrations, neutralization reactions, which we'll talk about later on. So for phenolphthalein, if phenolphthalein is placed in a solution of 8.2 pH or below, then that phenolphthalein will be colorless or clear. If that phenolphthalein is placed in a solution of 10 or above, that phenolphthalein will turn pink. One last one I would like to take a look at is litmus. Litmus could be a solution, or it could be litmus paper. Now, litmus paper comes in 2 forms, red and blue. Litmus, if in a solution of a pH 5.5 or below, it's going to be red. Or if it's in a solution of 8.2 or above, it is going to be blue. When we test the pH of certain substances using litmus paper, we often use both red and the blue. If we put both the red and the blue in solution, and they both turn or stay red, then we say the solution is acidic. If we put both the red and the blue in a solution, and they both turn or stay blue, we say that it is basic. If one's red and one's blue, then we have to do a little bit more experimentation. It might be neutral. Let's do some practice problems together. Here we have a pH data table. We have 4 substances where we'll have to find the pH, determine whether it's an acid or a base, and determine the color of the specific pH indicator for that substance. Here we have a pH scale that goes from 0 to 14. on this particular pH scale, at 0, the most acidic, we have battery acid. And on the other side, the most basic, at 14, is going to be drain cleaner. The first substance is coffee. Coffee comes in with a pH of 5. Since 5 is less than 7, coffee is considered acidic. Anything lower than 7 is an acid. Now it's asking for the color of litmus. So we go to table M, we find litmus, and remember the pH of coffee is 5. So is the number 5 lower than 5.5 or greater than 8.2? Well, obviously, the number 5 is lower than 5.5, the number on the left of column 2. So the color is going to be the color on the left of column 3. Since the pH is lower than 5.5, the litmus will be red in this coffee solution. The second substance, bleach, has a pH of 13. So we'll write that in, a pH of 13. Remember, anything greater than 7 is going to be basic. So a substance like bleach with a pH of 13 will be considered a base. Now we have to determine the color of phenolphthalein in this bleach solution. The bleach solution, once again, has a pH of 13. We find phenolphthalein, which is right here. 13 is greater than 10, the number on the right, so it's going to correspond to the color on the right. In this case, the phenolphthalein will be pink in a solution with a pH of 13. The third substance, egg whites. We go to the pH scale, we see egg whites have a pH of 9. Once again, the number 9 is greater than 7, so that is going to be considered a base. This time we're looking at bromocressyl green. Remember, pH of 9, bromocressyl green. We find bromocressyl green here towards the bottom. The number 9 is greater than 5.4. The number on the right. So it's going to correspond to the color on the right. In this case, it is blue. So, bromocressyl green in a substance, a solution with a pH of 9, is going to turn blue. Finally, we have soda. Soda has a pH of 3. A pH less than 7 is going to be acidic. So coffee is considered an acid. And now we have to find what color methyl orange will be in this solution that has a pH of 3. So we find methyl orange is the very first one on table M. The number 3 is less than 3.2, this number on the left side. So that corresponds to the color on the left side of column 3, which is red. So, methyl orange in soda, which has a pH of 3, will turn red. Practice problem number 1 states, in which 0.01 molar solution is phenolphthalein pink. So we look at table M, we find phenolphthalein, and we see that phenolphthalein is pink, the color on the right side of column 3, at a pH value of 10, the number on the right side of the second column, the middle column, so 10 and above. But for problem number 1, we don't have pH values. So we have to think that a pH value of 10 or above must be a base. In order to solve this problem, we're going to need table K and table L. More importantly is table L, because we're looking for a base. If we go through the choices, letter A, CH3OH, you're not going to find on either table K or table L. It is not an acid or a base. It's actually methanol, which we will learn more about once we do organic chemistry. Letter B, calcium hydroxide, CaOH2, you will find on table L. It is definitely a base. It is the third one down on table L. Letter C, CH3COOH, that is on table K. This is acetic acid or ethanoic acid. So it's an acid. So it can't be choice C. Finally, letter D, HNO3 on table K, that's nitric acid. It's an acid, so it can't be choice D. Our correct answer is letter B. Problem number 2 asks, in which solution will thymol blue indicator appear blue? So we look at table M. We see that thymol blue is the last indicator on table M. And thymol blue will be blue, the color on the right, at a pH of 9.6 or above. The number, the pH value on the right. If we look back to the choices, once again, we do not see pH values. So we have to think a pH value of 9.6 and above, that, once again, would be a basic solution. And we find bases on table L. If we look through the choices, letter A, 0.1 molar CH3COOH, that's acetic acid or ethanoic acid. In that case, the acid would have a pH value of less than 7. So thymol blue would be yellow. Can't be choice A. 0.1 molar KOH for choice B. That's a base. That's on table L. This is potassium hydroxide. It's the second one down on table L. So this could be the correct answer. Let's take a look at the other choices. C, 0.1 molar HCl. That's the very first acid on table K. So it cannot be hydrochloric acid. And let's take a look at D, 0.1 molar H2SO4. That's sulfuric acid, also on table K. So it cannot be choice D. Our answer is choice B, a 0.1 molar solution of potassium hydroxide. Problem number 4 is a tricky one. Problem number 4 states, which indicator would best distinguish between a solution with a pH of 3.5 and a pH of 5.5? Then it gives us 4 choices. Let's take them one at a time. Bromothymol blue. Bromothymol blue goes from 6.0 to 7.6. So at 3.5, bromothymol blue, 3.5 is less than 6.0, so it'll be yellow. And at 5.5, also less than 6.0, it'll also be yellow. So going from 3.5 to 5.5, bromothymol blue doesn't change, so it would not be a good indicator for that range. The second one, bromocresol green, let's take a look. So at 3.5, bromocresol green would be, that's less than 3.8, so it would be yellow. And at 5.5, that's greater than 5.4, so at 5.5, bromocresol green would be blue. So that is a good choice. That does change from 3.5 to 5.5. Let's take a look at litmus. Litmus at 3.5. Litmus at 3.5, that's below 5.5, so it's going to be red. And at 5.5, litmus is also going to be red. So litmus would not be a good indicator for this range. Finally, we have thymol blue at 3.5. that's less than 8. So at 3.5, Thymol blue is going to be yellow. And at 5.5, Thymol blue, still less than 8, will also be yellow. Thymol blue does not change during this pH range, so it would not be a good indicator for this range. The best indicator for a range of 3.5 to 5.5 would be Rome Crescel green. 3.5 it's yellow, at 5.5 it is blue. Thank you for joining Mr. Alvarez's virtual chemistry classroom. Today we took a look at Table M of the chemistry reference tables. Table M, common acid-base indicators, consists of 6 different acid-base indicators, the pH range in which they detect the pH value of a solution, and the colors in which they turn to over that specific pH range. Remember, the pH value on the left side of the second column corresponds to the color on the left side of the third column, while the pH value on the right side of the second column corresponds to the color on the right side of the third column. Thank you again for joining us. I hope you learned something today. Please join us again soon.